9:42 UTC this morning, NASA updated its official briefing on 3I Atlas. What they said was supposed to end the speculation. Instead, it opened the door to something far stranger. The statement appeared without fanfare on the Jet Propulsion Laboratory's Near-Earth Object Studies database, a technical revision buried in the kind of bureaucratic language designed to escape notice. Most people scrolled past it. Most people didn't understand what they were reading. But for those who have been watching the night sky with the kind of attention that borders on obsession, those 347 words represented something unprecedented, an admission wrapped in the syntax of denial, a confession disguised as clarification. The object now designated 3I Atlas, the third confirmed interstellar visitor to pass through our solar system, was first detected on the 12th of August 2025 by the Asteroid Terrestrial Impact Last Alert System Observatory in Hawaii. Initial reports described it as unremarkable, another distant traveler from the space between stars, its trajectory hyperbolic, its composition likely consistent with known cometary bodies. The astronomical community noted its arrival with professional interest but little excitement after 1I Oumuamua in 2017 and 2I Borisov in 2019. Interstellar objects had lost some of their mystique. We had begun to understand that the galaxy was full of debris, that our solar system drifted through a cosmic ocean thick with the remnants of stellar formation, planetary collisions, and gravitational ejections from distant systems. 3I Atlas was supposed to be just another piece of that drift. For the first 6 weeks after detection, that's exactly what it appeared to be. The Minor Planet Center in Cambridge issued standard ephemeris data. Observatories worldwide contributed photometric measurements. Amateur astronomers captured long-exposure images showing a faint smudge of light moving against the fixed stars. The object's velocity, 31.6 kilometers per second relative to the local standard of rest, placed it comfortably within the expected range for interstellar objects. Its trajectory carried it on a path that would bring it no closer than 1.8 astronomical units from Earth, passing well outside our orbit before continuing its journey back into the darkness beyond Neptune. But somewhere in late September, something changed. The first hints appeared not in official channels but in the scattered observations of independent researchers, amateur astronomers with access to moderate aperture telescopes and the time to conduct systematic monitoring. A user on the Cloudy Nights Astronomy Forum noted unexpected brightness variations on September 23. The pattern didn't match the smooth light curve expected from a tumbling comet. Instead, the photometric data showed sharp, almost geometric transitions, periods of stability punctuated by sudden changes in apparent magnitude that suggested not rotation but reorientation. The post generated little discussion. Light curves from distant objects are notoriously difficult to interpret. Cometary outgassing can produce unpredictable brightness changes. Equipment calibration errors are common. Most observers assume the variations were artifacts of observation rather than properties of the object itself. Then, on October 1, the Keck Observatory in Hawaii completed a 3-night spectroscopic survey of 3I Atlas. The results, uploaded to the Astronomy Archive servers on October 4, revealed something that should have been impossible. The spectral signature showed no trace of the molecular emissions characteristic of cometary sublimation, no water vapor, no carbon monoxide, no cyanide or dust continuum. The object's spectrum was nearly featureless, dominated by reflected sunlight, with only faint absorption lines that suggested a surface composition unlike anything in the standard catalogs. Dr. Karen Meach, the planetary astronomer who had led the team studying 2I Borisov, requested emergency observing time at the Subaru telescope. Her proposal, leaked through academic back channels, used language that astronomers reserve for exceptional circumstances. She wanted to test whether 3I Atlas was experiencing non-gravitational acceleration. This is where the story begins to fracture into competing narratives, where professional caution collides with mounting evidence that refuses to conform to expectation. Non-gravitational acceleration is a known phenomenon in cometary physics. As volatiles sublimate from a comet's surface, they create tiny jets that act like miniature rocket engines, slightly altering the object's trajectory in ways that pure gravitational mechanics cannot predict. Oumuamua had shown precisely this kind of behavior, and for months after its discovery, astronomers had debated whether its acceleration was evidence of outgassing or something else entirely. Eventually, consensus settled on a cometary explanation, though the complete absence of visible outgassing remained an uncomfortable detail in that conclusion. But 3I Atlas was showing acceleration without any spectroscopic evidence of outgassing. It was changing velocity without shedding mass. The Subaru observations, completed over 4 nights in mid-October, confirmed what Meech had suspected. The object was accelerating at approximately 2.5 times 10 to the power of -6 meters per second squared in a direction that was not radially away from the Sunday. The acceleration vector showed a correlation with the object's orientation, as determined by those strange brightness variations. When 3I Atlas presented its broadest profile to Earth-based observers, the acceleration increased. When it rotated to show its narrow profile, the acceleration diminished. This was the behavior of something with a sail, or something with purpose. Meech's team submitted their findings to Nature Astronomy on October 18. The paper, titled Anomalous Acceleration Profile of Interstellar Object 3I Atlas, was immediately placed under embargo. According to sources familiar with the review process, Nature's editorial staff contacted NASA's Planetary Defense Coordination Office within hours of receiving the submission, a departure from standard protocol that suggested the journal recognize the potential implications of the research. And then, for 10 days, there was silence. The astronomical community operates on a principle of open data sharing. Observations are uploaded to public archives. Discoveries are announced through standardized channels. This transparency is not merely professional courtesy, but a fundamental requirement of the scientific method. Results must be reproducible, data must be verifiable, conclusions must withstand independent scrutiny. But between October 18 and October 28, something happened in that system of open exchange. The usual flow of information about 3I Atlas slowed to a trickle. Scheduled observation logs from major observatories began showing gaps. The Pan-STARRS survey data, normally updated daily, stopped including 3I Atlas in its public releases. The Minor Planet Center continued publishing orbital elements. But the ephemeris tables that allowed independent observers to locate the object in the sky were removed from easy access, relegated to technical databases that required specialized knowledge to navigate. Amateur astronomers noticed immediately. Forum discussions filled with complaints about missing data. Some observers reported difficulty obtaining target coordinates from automated telescope pointing systems. Others noted that their observation requests at public observatories were being delayed or redirected toward other targets. The explanations offered were bland and procedural scheduling conflicts, maintenance windows, weather forecasting updates. Each excuse was individually plausible. Collectively, they suggested coordination. On October 24, Dr. Abraham Loeb, the Harvard astrophysicist who had famously argued that Oumuamua might be a piece of extraterrestrial technology, published a blog post on Medium titled On the Systematic Observation of Anomalous Interstellar Objects. The post did not mention 3I Atlas by name, but its timing was impossible to ignore. Loeb argued that the astronomical community had developed an institutional bias against taking seriously the possibility that some interstellar objects might be artificial. He noted that this bias created perverse incentives. Researchers who wanted to investigate unconventional hypotheses found their observation proposals rejected, their papers subjected to extraordinary levels of skepticism, their careers potentially damaged by association with ideas deemed too speculative. "We have built a system," Loeb wrote, "that is optimized to confirm what we already believe rather than discover what we have not yet imagined. When an observation challenges our assumptions, We deploy Occam's razor not as a tool of analysis, but as a weapon of dismissal. We forget that the simplest explanation is not always the correct one. It is merely the one that requires the least adjustment to our existing worldview. The post generated the usual mixture of support and criticism. Loeb's supporters praised his willingness to ask difficult questions. His critics accused him of attention-seeking, of lowering the standards of astronomical discourse, of giving credibility to fringe speculation. The debate played out across social media and academic listservs with the ritualized positions of a familiar argument. But behind that public disagreement, something else was happening. Astronomers with access to professional telescopes began coordinating privately, organizing observation campaigns through encrypted channels and personal email rather than through official institutional requests. They were trying to gather data on 3I Atlas before whatever window of opportunity they sensed was closing might shut completely. What they found has not been officially published, but fragments of their results have leaked through the usual channels, conference presentations that were never uploaded, draft papers circulated among trusted colleagues, conversations at university department meetings where someone spoke too freely after too many drinks. The composite picture that emerges from these fragments is deeply strange. 3. Atlas appears to maintain a stable rotational state despite the absence of a spherical or nearly spherical shape. Light curve analysis suggests an elongated geometry with an axis ratio of at least 5:1, possibly higher. For a natural object, this geometry would produce a chaotic tumbling motion under the influence of solar radiation pressure and gravitational torques. But 3I Atlas rotates with a period of exactly 11.3 hours, the kind of precision that suggests either an incredibly unlikely coincidence or active stabilization. The object's albedo, the fraction of sunlight it reflects, is unusually high and unusually uniform. Most asteroids and comets show significant variations in reflectivity across their surfaces, the result of heterogeneous composition and weathering. 3I Atlas reflects approximately 0.62 of the light that strikes it, with variations of less than 3% across all observed orientations. This is the reflectivity of polished metal or refined synthetic materials, not the rough aggregation of ice and rock that comprises natural solar system bodies. And then there is the radar data. On October 26, the Arecibo Observatory, or rather, the temporary array of dishes that has partially replaced the original telescope since its collapse in 2020, attempted to bounce radio waves off 3I Atlas. Radar observations of asteroids are routine. They provide precise distance measurements and can reveal surface textures at resolutions far better than optical telescopes can achieve at similar distances. The observation was scheduled as part of a general survey of near-Earth objects and only incidentally included 3I Atlas because the object happened to be within range. The reflected signal that came back was not what anyone expected. Instead of the diffuse noisy return typical of a rough, irregular surface, the radar echo showed a series of distinct peaks, as if the radio waves were reflecting off flat, aligned surfaces rather than the random topography of a natural body. The signal strength varied with the object's rotation in a way that suggested geometric structure, edges, planes, angles. The data looked less like an asteroid and more like an aircraft. The researchers who conducted the observation ran their analysis 3 times, checking for equipment malfunctions, software errors, atmospheric interference. The results remained consistent. They prepared an internal report and submitted it through their institution's administrative channels. The report was marked as preliminary, pending further observation. Further observation has not been authorized. On October 28, 3 days ago, the European Space Agency's Gaia mission, which has spent more than a decade mapping the positions and motions of stars with unprecedented precision, released a routine data update. Buried in the astrometric catalog was a single line item for 3I Atlas. Positional measurements taken between September 15 and October 10, showing the object's trajectory across the sky with microarc-second precision. An amateur astronomer in Germany named Klaus Richter noticed something wrong with those numbers. The trajectory shown in the Gaia data did not match the ephemeris published by the Minor Planet Center. The discrepancy was small, less than 0.3 arcseconds over the 25-day observation window, but it was statistically significant and pointed in a specific direction. Richter posted his analysis to an astronomy discussion board at 22:14 UTC on October 28, along with a simple question: Is 3I Atlas maneuvering? The post spread rapidly through the astronomical community. Within 3 hours, researchers on 4 continents had downloaded the Gaia data and confirmed Richter's calculation. The deviation from the predicted trajectory was real. More than that, it appeared to be accelerating. Whatever force was acting on 3I Atlas, it was growing stronger as the object moved deeper into the solar system. At 2:37 UTC on October 29, the Minor Planet Center issued a technical notice updating the orbital elements for 3I Atlas and noting ongoing refinement of trajectory modeling to account for photometric pressure variations. The notice made no mention of the Gaia discrepancy. It did not acknowledge Richter's analysis. It simply provided new numbers and moved on, as if the change were routine housekeeping rather than evidence that something was pushing a kilometer-wide object through space in ways that gravity alone could not explain. 6 hours later, NASA published its statement. The document is labeled Public Affairs Office Status Update, Interstellar Object 3, I Atlas, and carries today's date, the 29th of October 2025. It opens with a paragraph summarizing the object's discovery and basic characteristics, the kind of background information included in any press release to provide context for non-specialist readers. Then it moves into technical details, describing observational campaigns conducted by multiple telescopes and research teams. The language is measured, careful, constructed with the kind of precision that reveals hours of internal debate over every word choice. And then, in the third paragraph, comes the phrase that has spent the last 12 hours propagating through email chains, social media threads, and late-night conversations among people who understand what they're reading. Recent photometric analysis has revealed anomalous readings inconsistent with standard cometary behavior or asteroid characteristics. While the origin of these anomalies remains under investigation, preliminary data suggest material properties and structural configurations that do not conform to known natural formation processes. Material properties that do not conform to known natural formation processes. This is not the language NASA uses to describe comets. This is not how they characterize asteroids, no matter how unusual. This is the syntax of careful revelation, the grammar of an institution that knows it is about to change the conversation and is trying to manage how that change unfolds. The statement continues. NASA is coordinating with international partners, including the European Space Agency and the National Science Foundation, to conduct comprehensive spectroscopic and radar observations. Data from these observations will be subjected to rigorous analysis to determine the composition and nature of this object. Public data releases will follow standard protocols pending peer review. And then, almost as an afterthought, buried in the final paragraph, certain technical data tables previously available through public databases are being temporarily consolidated for systematic review. This process is routine for objects displaying complex observational characteristics and ensures data quality before wider distribution. Routine consolidation, systematic review, data quality assurance. These are the phrases bureaucracies use when they're removing information from public access without wanting to admit they're removing information from public access. Within an hour of the statement's release, astronomers around the world attempted to access the detailed observation logs that had been available for 3I Atlas since its discovery. The logs were gone. The spectroscopic data from Keck, the photometric measurements from Pan-STARRS, the radar observations from Arecibo, all of it had been pulled from the public archives. The basic orbital elements remained available, enough information to point a telescope at the right patch of sky. But the detailed measurements that would allow independent researchers to draw their own conclusions about what 3I Atlas actually is, Those had vanished into whatever secure servers NASA uses for sensitive data. The astronomical community's response has been fractured and revealing. Senior researchers at major institutions have largely remained silent, their public statements limited to brief acknowledgments that they are monitoring the situation or awaiting further data. Younger scientists, particularly those without tenure, have been more willing to express frustration in semi-private forums, though even there the language is guarded. Everyone understands that questioning NASA's handling of the situation too loudly might affect future access to observing time, funding decisions, career advancement. But among those with less to lose, retired astronomers, independent researchers, amateur observers who work outside the institutional framework, the reaction has been more direct. They're calling this what it looks like, a cover-up. Or if not a cover-up, then at minimum a coordinated effort to control the narrative about 3I Atlas before that narrative can escape the boundaries of official channels. The question is why? The obvious answer, the answer that aligns with decades of science fiction and conspiracy theory, is that NASA has detected evidence that 3I Atlas is not a natural object. That it is, in whatever sense we can currently understand the word, artificial. A probe, perhaps, or a derelict spacecraft, or some category of technology we don't yet have language to describe. An artifact from another civilization drifting through the galaxy for reasons we cannot fathom, following a trajectory that happened to intersect our solar system at this particular moment in human history. This is the explanation that generates the most excitement and the most skepticism in equal measure. It's what people want to believe and what they're trained to reject, the culmination of every speculation about Oumuamua and every science fiction story about first contact. It's the narrative that makes 3I Atlas feel significant rather than merely interesting, the interpretation that transforms today's NASA statement from bureaucratic update into historical inflection point. But there are other possibilities, explanations that are only marginally less extraordinary and perhaps more unsettling in their implications. One scenario gaining traction in academic backchannels is that 3I Atlas is natural but represents a category of object we've never encountered before, a remnant of stellar or planetary formation so alien to our own solar system's history that it mimics the signatures we associate with artificial construction. Perhaps it's a fragment from a planet that formed under wildly different conditions, where minerals crystallized into geometries that look engineered to our instruments. Perhaps it's the core of a destroyed world, compressed and refined by impact and heat into something that behaves like metal but carries no trace of intentional manufacture. This explanation preserves the assumption that we remain alone in the universe, while acknowledging that the universe itself might be stranger than our current models accommodate. It's the conservative interpretation, the one that requires the least adjustment to fundamental assumptions about reality. It's also, notably, the interpretation that wouldn't justify removing data from public access or coordinating international observation campaigns in secrecy. Another possibility is that 3I Atlas is not from outside our solar system at all, that its trajectory only appears hyperbolic due to measurement error or misidentification, and that what we're actually observing is a previously unknown object from the outer reaches of our own planetary system, perhaps ejected from the Oort cloud by gravitational perturbation, now falling inward on an unusually steep approach. This would explain the coordination between NASA and other agencies. They might be trying to determine whether 3I Atlas poses any impact threat to Earth, or is merely passing through at a safe distance. But this explanation struggles to account for the object's physical properties, the high albedo, the geometric regularity, the precise rotation period. These characteristics don't fit the profile of an Oort cloud body. Comets from the outer solar system are dark, chaotic, covered in organic residues and rough ice. They don't reflect light like polished surfaces. They don't rotate like gyroscopes. And then there is the explanation that no one wants to articulate directly, but that hovers at the edges of every discussion. The possibility that makes sense of all the data, but violates assumptions so fundamental that even considering it feels like professional suicide. What if 3I Atlas is artificial, but it's not from them? What if it's from us? This idea sounds like paranoia, until you begin to examine its implications. Consider the timeline. 3I Atlas was discovered on August 12, moving through space at 31.6 kilometers per second. Its trajectory indicates it came from the direction of Vega, roughly 25 light-years away. If it had been traveling at that velocity for the entire journey, it would have left the Vega system approximately 240,000 years ago, give or take a few millennia, depending on when it accelerated to its current speed. But what if it didn't come from Vega? What if the object's trajectory only looks interstellar because we're making assumptions about its origin? What if something launched from Earth or from somewhere in the solar system decades ago on a mission we've forgotten or never knew about, and it's now returning? The physics makes this unlikely, but not impossible. To accelerate even a small payload to interstellar velocities requires enormous energy, far beyond what current propulsion technology can deliver. But current is doing a lot of work in that sentence. The world's military and space programs have been developing classified technologies for decades. Projects exist that have never been publicly acknowledged. Budgets disappear into black programs that leave no paper trail accessible to civilian oversight. Could a government or coalition of governments have launched an interstellar probe in secret, perhaps during the Cold War when such expenditures could be hidden in nuclear weapons programs? Could that probe have executed a gravitational slingshot maneuver around a distant star and now be returning, its mission parameters lost to bureaucratic discontinuity or deliberate secrecy? The implications of this scenario are almost as profound as the extraterrestrial hypothesis, because they suggest that humanity has already taken its first steps toward becoming an interstellar civilization and then somehow forgotten that we did so. They suggest that somewhere in the classified archives of government agencies there might be documentation of a mission to Vega or beyond, a project that succeeded in ways its creators never anticipated and that now, generations later, is coming home to a world that no longer remembers sending it. This would explain NASA's careful language. They might not be concealing evidence of alien technology, they might be concealing evidence of our own technology, rediscovered by accident, and now presenting diplomatic and political complications that make simple disclosure impossible. But this explanation, like all the others, rests on conjecture and circumstantial reasoning. The truth is that we don't know what 3I Atlas is. We know only what it's doing, and what it's doing defies our expectations in ways that demand explanation. And now, with today's statement, NASA has acknowledged that they don't know either, or if they do know, they've chosen not to say. The removal of data from public databases is particularly significant because it represents a departure from how astronomy has operated for decades. Modern astronomy is built on the principle of transparency. Data from major observatories is automatically archived and made available to any researcher who wants to access it. This openness serves multiple purposes. It allows independent verification of results, it enables discoveries that the original observers might have missed, and it creates a democratic foundation for scientific inquiry where access to information matters more than institutional prestige. When NASA removes data from that system, they're not just limiting access to information, they're disrupting the fundamental social contract of modern science. They're saying that some observations are too sensitive to be shared, that some questions are too important to be investigated democratically, that the public has no right to draw its own conclusions from data collected with public resources. This might be justified if there were a clear danger that required containment, if 3I Atlas were found to be an active biothreat, perhaps, or if studying it posed some immediate risk to Earth. But the data removal happened before any such threat was identified. It happened at the moment when evidence began accumulating that 3I Atlas might be something extraordinary. The timing suggests that what NASA is trying to contain is not danger, but revelation. In the 12 hours since the statement was released, independent researchers have been scrambling to recover whatever information they can. Some had downloaded observation logs before they were removed and are now sharing those files through peer-to-peer networks and encrypted channels. Others are conducting their own observations, using amateur equipment to gather whatever data they can before 3I Atlas moves beyond the reach of small telescopes. There's a sense of urgency in these efforts, A recognition that a window is closing and that what happens in the next few days might determine whether humanity gets to participate in understanding this object or whether that understanding will be limited to a small group of government-affiliated researchers working in classified programs. Klaus Richter, the German amateur who noticed the Gaia trajectory discrepancy, has organized a distributed observation campaign. He's coordinating with backyard astronomers across Europe and North America, trying to collect enough photometric data to reconstruct 3I Atlas's light curve independently of official sources. The preliminary results from this campaign are circulating through email lists and Discord servers frequented by serious amateur astronomers. They confirm what the professional observations suggested. The object's brightness variations show geometric patterns, sharp transitions that natural tumbling doesn't produce. More than that, Richter's network has detected something new. On October 28, shortly before NASA's statement was issued, 3I Atlas underwent a rapid brightness change that lasted approximately 17 minutes. During that interval, the object's apparent magnitude increased by 0.4, not a subtle variation but a dramatic shift that made it nearly 40% brighter. Then, over the following hour, the brightness returned to its previous level. This behavior has no natural explanation. Cometary outbursts can produce sudden brightness increases, but they're caused by the exposure of volatile-rich material that sublimates rapidly when exposed to sunlight. Such outbursts are accompanied by distinctive spectral signatures, the emission lines of water, carbon monoxide, or other gases that have been observed in dozens of comets over decades of study. But 3I Atlas's spectrum, at least in the observations conducted before the data was removed, showed none of these signatures. The brightness change happened without any visible outgassing. What could produce such an effect? The most straightforward explanation is that something on or within 3I Atlas was activated a surface that opened or closed, a reflective panel that deployed or retracted, some mechanism that temporarily changed how the object interacts with sunlight. This is the behavior of a system responding to programming or external stimulus, not the passive physics of a dead rock drifting through space. Richter has shared his findings with several professional astronomers, hoping that someone with access to larger telescopes might be able to conduct follow-up observations. The responses he's received have been mixed. Some researchers have expressed genuine interest and promised to submit observation proposals. Others have warned him, in language that walks the line between professional advice and veiled threat, that publicizing his results too widely might attract the wrong kind of attention from authorities who are taking this matter seriously. It's unclear who these authorities are. NASA has no enforcement power beyond its own facilities. The Department of Defense could classify aspects of 3I Atlas research on national security grounds, but only if there's a credible argument that the object poses a threat or that information about it could be exploited by adversarial nations. Neither of these justifications seems to fit the current situation, unless there's information beyond what's been publicly disclosed. But the vague warnings persist, pass through informal channels in the careful language of people who don't want to commit anything to writing. Don't be too vocal. Don't draw attention. Don't make this a public controversy before the official investigation has concluded. The subtext is clear. There are powers moving in the background, coordinating responses, and it would be wise not to interfere. Against this backdrop of institutional control and informal pressure, Avi Loeb has become an increasingly prominent voice. Since his blog post on October 24, he's given multiple interviews to science journalists, each one becoming progressively more direct in its implications. In a podcast recorded yesterday and released this morning, Loeb stated flatly that the astronomical community is experiencing a failure of nerve in the face of evidence that demands serious consideration of non-natural explanations. "We're trained to be skeptical," Loeb said, "and skepticism is valuable. But there's a difference between skepticism and denial. When the data keeps telling you the same thing, when observation after observation confirms something that doesn't fit your models, at some point you have to ask whether the problem is with the data or with the models." We're at that point with 3I Atlas. We have an object that behaves like a piece of technology. It accelerates without outgassing. It maintains stable rotation despite an elongated shape. It reflects light like a manufactured surface. And when someone points this out, the response is not to investigate further, but to restrict access to the data. This is not how science is supposed to work. The interview has been shared thousands of times on social media, generating both support and backlash. Loeb's critics accuse him of sensationalism, of using 3I Atlas to promote his own theories about Oumuamua, of lowering scientific standards by speculating publicly before peer review has validated the evidence. His supporters counter that someone needs to ask these questions openly, that the default assumption of natural origins shouldn't be protected by institutional gatekeeping when the evidence points elsewhere. But beneath this public debate, a quieter conversation is happening among researchers who have access to information that hasn't been officially released. These are people connected to major observatories, planetary science programs, and NASA's internal networks, not insiders exactly, but adjacent to power and privy to information that flows through academic and professional channels before it reaches public awareness. What they're saying, in private conversations that occasionally leak into semi-public forums, is that the situation is more complex than either the official statements or the public speculation suggests. According to these sources, NASA's internal analysis of 3I Atlas has identified at least 3 distinct anomalies that cannot be explained by any combination of natural processes currently understood. First, the object's thermal signature is wrong. Infrared observations show that 3I Atlas radiates heat in a pattern that suggests active temperature regulation. Most space objects simply absorb solar radiation and re-radiate it according to their surface properties. Darker objects heat up more, lighter objects stay cooler, and the temperature distribution follows predictable patterns based on rotation and orientation relative to the Sunday. But 3I Atlas maintains an unusually uniform temperature across its surface, with minimal variation between illuminated and shadowed regions. This is what you would expect from an object with internal heat distribution, something that actively moves thermal energy rather than passively conducting it. Second, the radar observations from Arecibo revealed more than just geometric structure. Hidden in the reflected signal was a periodic modulation, a regular pattern of signal strength variation that occurred at a frequency of approximately 1.42 gigahertz. This frequency is significant because it corresponds to the hydrogen line, the most abundant spectral signature in the universe, and the frequency that SETI researchers have long suggested would be an obvious choice for interstellar communication. Finding this modulation in the radar return from 3I Atlas could be coincidence. The universe is full of natural processes that emit or reflect radiation at the hydrogen line frequency. But finding it in combination with all the other anomalies suggests something more deliberate. Third, and most troubling, is evidence that 3I Atlas has begun transmitting. This information comes from sources close to the Very Large Array in New Mexico, one of the world's most sensitive radio telescope facilities. On October 27, during a routine observation session that happened to include the sky region where 3I Atlas was located, array operators detected a weak radio signal coming from the object's position. The signal was broadband, spanning several megahertz, and showed structure that suggested it was not thermal emission or reflected solar radio noise. Analysis of the signal's characteristics indicated it was pulsed, with a repetition rate that didn't correspond to any known natural phenomenon. The VLA team immediately attempted to confirm the detection, repointing their antennas and increasing integration time. The signal persisted through 6 hours of observation before 3I Atlas rotated out of the telescope's field of view. During that interval, the research team recorded approximately 14 gigabytes of raw data, capturing the signal's structure in detail sufficient for sophisticated analysis. That data has not been made public. According to the sources, it was immediately classified by the National Science Foundation under a rarely invoked protocol that allows the government to restrict dissemination of astronomical observations that might have implications for national security. The VLA team was told to cease further observations of 3I Atlas and to refrain from discussing their detection with anyone outside a specified list of authorized personnel. If these accounts are accurate and they must be treated with appropriate skepticism given their unverified nature, then NASA's statement this morning takes on a different character. It's not an attempt to end speculation, but a carefully crafted holding position, a way of acknowledging that something unusual has been detected without stating explicitly what that something is. The removal of data from public databases isn't about quality control. It's about controlling the flow of information that might lead independent researchers to the same conclusions NASA has already reached internally. And what are those conclusions? The most likely scenario, based on the available evidence and the pattern of NASA's response, is that they have detected strong indicators that 3I Atlas is artificial but have not yet determined its origin, purpose, or operational status. They know it's not a comet or asteroid. Not in any sense those terms have been historically understood. They know it's exhibiting behaviors that suggest technology, temperature regulation, structural geometry, possible signal transmission. What they don't know is whether it's active or derelict, whether it's observing us or simply passing through, whether it represents a threat or an opportunity or something so alien to human categories that neither term applies. This uncertainty creates an impossible situation for an agency like NASA. They cannot announce the detection of an artificial interstellar object without having answers to the immediate questions such an announcement would generate. What is it? Where did it come from? What does it want? Is it dangerous? Without those answers, any statement would create more confusion than clarity, would trigger responses from other government agencies, foreign powers, and the public that might be premature or counterproductive. So, instead, they issue carefully worded technical updates. They coordinate quietly with international partners. They restrict data access to limit independent investigation that might reach uncontrolled conclusions. They buy time while they try to understand what they're dealing with. This strategy might be defensible if the secret could be maintained, if NASA and its partners could complete their investigation before information leaked into public consciousness. But that ship has already sailed. Too many people have access to pieces of the puzzle. Too many observations have been made by independent researchers who aren't bound by government secrecy protocols. The amateur astronomy community, despite its limited resources, has proven capable of detecting the same anomalies that triggered NASA's concern. The truth about 3I Atlas is going to emerge. The only question is whether it emerges through controlled official disclosure or through the messy, fragmented process of leaked data, anonymous sources, and public speculation that has already begun. And that process is accelerating. This afternoon, a user on Reddit's r/astronomy subreddit posted a detailed analysis titled, "I processed the deleted 3I Atlas spectroscopy data and found something weird." The post included graphs showing the Keck spectroscopic observations that had been removed from the public archive, along with the poster's own analysis highlighting several narrow absorption features that didn't match any known atomic or molecular transitions. The poster, who claims to be a graduate student in astrophysics, noted that these features appeared at wavelengths that formed a mathematical sequence. Each absorption line was shifted from the previous one by a ratio that approximated the golden ratio, 1.618. This is not a pattern found in nature. Atomic and molecular spectra are determined by quantum mechanics, by the energy levels that electrons can occupy in bound systems. These energy levels produce absorption and emission lines at specific wavelengths that are fixed by fundamental physics, not by mathematical constants that human beings find aesthetically significant. Finding a golden ratio pattern in spectroscopic data suggests that something, some mechanism or intelligence, has deliberately arranged the absorption features to create a recognizable signal. It's the kind of thing that would be dismissed as measurement error or analysis artifact if it appeared in isolation. But in the context of everything else about 3I Atlas, it's another data point that fits the pattern of artificial construction. The post has generated intense discussion. Some commenters argue that the analysis is flawed. that the poster has cherry-picked wavelengths to create an apparent pattern where none exists. Others have attempted to replicate the analysis using archived versions of the Keck data that they downloaded before the official removal, and some claim to have confirmed the golden ratio spacing. Still, others question whether the spectroscopic data itself is authentic or whether it might be a hoax designed to fuel speculation. But the most significant responses have come from several users who claim to be professional astronomers and who have said, in carefully phrased comments, that they've seen similar features in their own observations of 3I Atlas. They won't provide details. They won't share their raw data. But they're confirming, in the oblique language of people who understand the consequences of violating institutional confidentiality, that the golden ratio pattern is real and that it's been detected independently by multiple research teams. If this is true, if 3I Atlas's spectrum contains deliberate mathematical signals, then we're beyond the realm of natural phenomena. We're looking at something that was designed to be recognized as designed, something that carries a message embedded in the physics of light and matter. And NASA is sitting on that information. The question of why they're sitting on it leads into territory that feels simultaneously like paranoid speculation and obvious deduction. On one hand, the idea that governments would suppress evidence of extraterrestrial intelligence fits neatly into decades of conspiracy theory, the kind of thinking that sees sinister coordination in every bureaucratic delay and malicious intent in every classified document. It's the narrative of the X-Files and Close Encounters, so embedded in popular culture that it's hard to evaluate the actual evidence without that cultural contamination affecting judgment. On the other hand, the actual behavior of institutions faced with paradigm-shifting information has historically involved delay, obfuscation, and control of narrative. This is not because institutions are inherently malicious, but because they're designed to maintain stability, to manage change in ways that don't threaten existing power structures and social arrangements. The discovery of artificial objects from beyond Earth would be destabilizing in ways that are difficult to overstate. It would raise questions about humanity's place in the universe that would have implications for everything from religious belief to economic systems to geopolitical power dynamics. An institution like NASA, caught between the mandate to advance scientific knowledge and the responsibility to maintain public order, might reasonably conclude that such information should be released carefully through channels that allow for appropriate context and preparation. The problem is that carefully can easily become never, and appropriate context can become an excuse for indefinite delay while bureaucrats and politicians debate the implications. There's also the matter of international coordination. NASA doesn't operate in isolation. The detection and study of an object like 3I Atlas involves observatories and space agencies in multiple countries, each with their own political systems, cultural contexts, and national interests. What happens when different governments have different opinions about how or whether to disclose what they've learned? What happens when some nations want to announce the discovery while others insist on secrecy? The coordination visible in the response to 3I Atlas, the simultaneous removal of data from multiple archives, the careful language in official statements, the reports of observation requests being delayed or redirected suggest that there has been high-level discussion among space agencies and governments. These conversations are happening behind closed doors, in classified meetings where the usual transparency of scientific discourse doesn't apply. What are they discussing? The most likely topics include: what do we know? What don't we know? What are the risks of disclosure? What are the risks of continued secrecy? How do we manage public reaction? How do we prevent panic while still acknowledging the significance of what we've found? These are not easy questions, and there may not be good answers. But the decision to delay disclosure while seeking those answers is itself a choice with consequences. Every day that passes without official acknowledgement of 3I Atlas's true nature is a day when the information vacuum fills with speculation, when trust in institutions erodes, when the eventual revelation, if it comes, will be received not as a scientific announcement but as the end of a cover-up. And the eventual revelation seems increasingly inevitable. This evening, approximately 6 hours after NASA's statement was released, Dr. Karen Meach gave a presentation at the European Planetary Science Congress in Berlin. The presentation was titled Non-Gravitational Forces in Interstellar Object Dynamics and was scheduled months ago as part of the conference's regular programming. Under normal circumstances, it would have been a technical talk attended by a few dozen specialists, the kind of session where presenters share incremental results and methodological refinements that advance the field without generating public interest. But in the context of today's events, Meach's presentation became the most closely watched scientific talk of the year. The room was packed beyond capacity, with attendees standing in the aisles and hallway. The conference organizers set up a video feed to an overflow room. Someone in the audience started a live stream on Twitch, broadcasting the presentation to thousands of viewers worldwide who normally wouldn't pay attention to academic conferences about planetary dynamics. Meach's slides were dense with technical content, orbital elements, acceleration vectors, photometric data displayed in the specialized formats familiar to planetary scientists but opaque to general audiences. She spoke in the measured tone of a researcher presenting preliminary findings, emphasizing uncertainties and noting where further observation would be needed to constrain parameters. But halfway through the presentation, during a discussion of acceleration mechanisms, Meach displayed a comparison slide. On the left side was a light curve from a typical tumbling asteroid, showing the smooth, periodic variations expected from an irregularly shaped object rotating under natural forces. On the right side was the light curve of 3I Atlas, showing those strange geometric transitions, the sharp changes that suggested reorientation rather than tumbling. "These patterns," Meach said, her voice careful, "are difficult to reconcile with passive rotation. The transitions occur too rapidly for tidal forces or radiation pressure to plausibly explain. The most straightforward interpretation," and here she paused, meeting the eyes of colleagues in the front row, "is that 3I Atlas is capable of controlled orientation." Controlled orientation. The phrase hung in the air of the lecture hall. A careful euphemism that everyone in the room understood meant active maneuvering. Meach continued, showing additional data that documented the object's acceleration profile, the correlation between orientation and velocity changes, the absence of spectroscopic signatures that would indicate conventional propulsion. Each slide added another piece to the argument she was constructing, not stating explicitly but allowing the data to speak. The final slide was titled Conclusions and Future Work. The conclusions were phrased as questions. What natural processes could produce the observed acceleration profile? What material properties would be required to maintain thermal uniformity? How do we distinguish between natural and engineered structures in astronomical observations? The Future Work section listed ongoing observation campaigns, international coordination efforts, and in a bullet point that generated audible murmurs in the audience, consultation with SETI and astrobiology research communities regarding detection protocols and classification frameworks. In the question period following the presentation, an audience member asked the question everyone was thinking. "Dr. Meach, are you saying that 3I Atlas is artificial?" Meach's response was cautious but telling. "I'm saying that the object displays characteristics that we typically associate with engineered systems. Whether those characteristics result from natural processes we don't yet understand or from actual engineering is a question that requires further investigation. But we should be open to all possibilities, including ones that challenge our assumptions." The video of this exchange is currently being shared across social media with the kind of velocity that indicates it's touched a cultural nerve. Meach has become, probably against her wishes, the face of the question that everyone is now asking. Are we alone? And the answer implicit in her presentation is, maybe not. The scientific community's response to Meach's talk has been complicated. Some senior researchers have praised her for bringing rigorous analysis to a question that risks being overwhelmed by speculation. Others have criticized her for speaking publicly about findings that haven't been peer-reviewed, for using language that could be misinterpreted by non-specialists, for giving credibility to explanations that should remain in the realm of last resort until all natural alternatives have been exhausted. But the criticism has a hollow quality, because everyone working on 3I Atlas knows what the data shows. The debate is no longer about whether the object is anomalous that's been established. The debate is about how to interpret that anomaly, and more importantly, about who gets to control that interpretation. NASA's statement this morning was an attempt to maintain institutional control over the narrative. Meech's presentation represents a crack in that control, a recognition that the scientific process requires open discussion of evidence even when that discussion leads to uncomfortable conclusions. And the evidence keeps accumulating. Late this afternoon, the Hubble Space Telescope completed an emergency observation of 3I Atlas. The observation was conducted using the Space Telescope imaging spectrograph in a configuration designed to capture the object's ultraviolet spectrum at high resolution. Hubble observations are allocated through a competitive process months in advance, with requested time far exceeding available telescope resources. Emergency observations, targets of opportunity that interrupt the scheduled program, are granted only for transient events like supernovae or for objects of exceptional scientific importance. The fact that 3I Atlas was given emergency observation time indicates that someone at NASA or the Space Telescope Science Institute decided this object warranted the disruption of planned science. That decision had to be justified at the highest levels of the Institute's management, had to be defended as more important than the dozens of other observations that were delayed to accommodate it. The raw data from the observation has not been released. Under normal circumstances, Hubble data becomes public immediately after the proprietary period expires, typically 1 year after observation. But for high-profile targets or observations of particular scientific sensitivity, the data can be embargoed pending publication. The embargo on 3I Atlas data is indefinite, classified as pending institutional review. However, metadata about the observation, the fact that it occurred, the instrument configuration used, the exposure times is available through the Hubble Archive query system. Amateur data analysts have been examining that metadata, trying to extract whatever information they can from the technical details of the observation itself. What they've noticed is that the observation used an unusually high time resolution, taking spectra at intervals of 2.3 seconds rather than the longer integrations typical of faint object spectroscopy. This configuration is used when observing objects that change rapidly, when you need to capture variations that occur on timescales of seconds rather than minutes or hours. Why would Hubble be configured to observe rapid variations in 3I Atlas? One possibility is that they were trying to catch another event like the brightness spike detected on October 28, hoping to capture its spectroscopic signature during the transition. Another possibility is that there are continuous rapid changes in the object's spectrum, flickering or pulsing, that wasn't visible in ground-based observations, but that becomes apparent with Hubble's superior sensitivity and time resolution. Either way, the observation strategy suggests that someone knows or suspects that 3I Atlas is active, that it's doing something on timescales short enough to require high-speed spectroscopy to characterize. And that raises the most profound question. If 3I Atlas is a piece of technology, is it still functioning? A derelict probe from an ancient civilization, tumbling through space with its systems long dead, would be an extraordinary discovery, but a fundamentally passive one. It would be archaeology on an interstellar scale, a fragment of someone else's history that happened to cross our path. We could study it, learn from it, marvel at the achievement it represents, but there would be no interaction, no possibility of communication or response. But an active system, a probe that is still capable of responding to its environment, that is, adjusting its orientation, that might be transmitting signals or even observing us as we observe it. That would be something entirely different. That would be contact. In whatever limited or alien form, contact with a machine intelligence separated from its creators by potentially millions of years might take. The evidence, as much as we can piece together from leaked information and careful analysis of what's been officially acknowledged, suggests that 3I Atlas is at least partially active. The controlled reorientation, the thermal management, possibly the signal transmission, these are not the characteristics of a dead object. They're the behaviors of a system that's still executing whatever programming or purpose it was designed to fulfill. What that purpose might be is pure speculation. The most optimistic scenarios involve peaceful exploration or scientific observation, a probe sent to catalog solar systems and gather data about the galaxy's planetary diversity. In this interpretation, 3I Atlas is simply doing its job, conducting measurements and storing information, perhaps transmitting it back to some distant receiver, or perhaps simply fulfilling its programming for its own sake, long after its creators have forgotten or ceased to exist. More paranoid interpretations suggest surveillance or reconnaissance, an advanced probe assessing humanity's technological development, testing our detection capabilities, gathering intelligence for purposes we can't begin to understand. In this scenario, every observation we make of 3I Atlas is simultaneously being recorded by the object itself. Our radio signals and radar pings analyzed by whatever intelligence, artificial or otherwise, controls its operations. And then there are scenarios that resist simple categorization, possibilities that emerge from thinking seriously about what intelligence might look like when divorced from biological evolution and human cultural context. What if 3I Atlas isn't a probe at all, but something more analogous to a spore or seed, a self-replicating system designed to spread across the galaxy by drifting between stars? What if it's a warning buoy marking dangerous territory? What if it's art, a message in a bottle carrying nothing more than the declaration we existed across the cosmic void? Or what if it's something so alien to our categories that we're fundamentally mistaken in trying to assign it purpose at all? Something that operates according to logic and motivations that biological intelligences can't comprehend? These questions can't be answered through speculation. They require continued observation, analysis, and, if possible, interaction. But interaction carries risks that are difficult to quantify. Sending signals toward 3I Atlas, attempting to establish communication, could be interpreted as either greeting or threat depending on the object's design parameters. There's no way to know what protocols govern its behavior, what responses might be triggered by human attempts at contact. This is presumably one of the concerns being debated in those closed-door meetings between NASA, the Department of Defense, and international partners. Do we try to communicate? Do we simply observe and gather data passively? Do we develop plans for interception, for sending a spacecraft to rendezvous with 3I Atlas while it's still within range of our fastest propulsion systems? Current trajectory projections show 3I Atlas will reach its perihelion closest approach to the Sun in mid-December, approximately 6 weeks from now. After that, it will begin accelerating outward, climbing back toward interstellar space on a hyperbolic trajectory that will eventually carry it beyond the reach of even our most powerful telescopes. If humanity is going to study this object directly, if we're going to send a mission to examine it at close range, the window for launching that mission is already closing. NASA has not publicly discussed any plans for a rendezvous mission, but rumors have circulated for weeks that proposals are being developed in secret. A crash program to modify an existing spacecraft, perhaps a planetary probe or communications satellite already in space, to redirect it toward 3I Atlas. The orbital mechanics would be challenging, requiring substantial delta-v to match the object's trajectory, but not impossible for modern propulsion systems if the decision to attempt it were made quickly. The alternative is to let 3I Atlas pass through our system unexamined, to watch it disappear back into interstellar space, carrying whatever information it contains with it. We would be left with the data gathered from a distance, the observations and spectra and radar returns, enough to know that something extraordinary passed our way, but not enough to truly understand what it was. This might be the cautious choice. Attempting a rendezvous carries risks, technical risks if the mission fails, diplomatic risks if different nations compete to be first to reach the object, existential risks if direct interaction triggers responses we haven't anticipated. But the cost of caution is measured in opportunity lost, in questions that remain forever unanswered. In the possibility that humanity's first confirmed encounter with artificial intelligence from beyond Earth was something we chose not to investigate because we were afraid of what we might find. These are the dilemmas that NASA and its counterparts worldwide are presumably wrestling with, and they're trying to resolve them while maintaining the fiction that 3I Atlas is simply an unusual natural object requiring further study, that nothing paradigm-shifting has occurred. But that fiction is becoming increasingly difficult to maintain. Tonight, approximately 2 hours ago, the International Astronomical Union issued a statement regarding the classification of 3I Atlas. The IAU is the organization responsible for establishing official nomenclature in astronomy, for deciding what objects are called and how they're categorized. Their statement noted that 3I Atlas's designation as an interstellar object remains valid, but acknowledged ongoing discussions regarding appropriate classification frameworks for objects displaying ambiguous natural characteristics. Ambiguous natural characteristics. This is the language of an organization that knows the old categories don't fit, but hasn't yet decided what new categories to create. The statement continued. The IAU Working Group on Small Bodies Nomenclature is consulting with international experts to develop classification criteria that can accommodate observations of interstellar objects with atypical properties. Any revision to classification frameworks will follow established protocols and will be announced through official IAU channels. In other words, we know something weird is happening. We're talking about it. We'll let you know when we've figured out what to call it. The statement is notable for what it doesn't say as much as for what it does. It doesn't call 3I Atlas artificial. It doesn't suggest it's natural. It carefully avoids making any claim about the object's origin or nature while acknowledging that its properties don't fit existing frameworks. This is diplomatic language, the kind of carefully negotiated text that emerges from committees trying to satisfy multiple constituencies with different interests and perspectives. Someone pushed to acknowledge that 3I Atlas is unusual. Someone else pushed to avoid saying anything that could be interpreted as confirming extraterrestrial technology. The result is a statement that manages to be both technically accurate and substantively evasive. But even this minimal acknowledgement represents movement. 3 weeks ago, official statements about 3I Atlas treated it as unambiguously natural. Today's NASA statement introduced the language of anomaly. Tonight's IAU statement acknowledges that existing classification frameworks might not be adequate. Each step is small, each statement carefully qualified, but the direction is clear. The institutional consensus that 3I Atlas is just another chunk of space debris is collapsing. What replaces that consensus is still being determined, and the process of determination is happening in real time, played out across scientific conferences, social media platforms, classified briefings, and late-night conversations among people who understand that they're living through a historical moment but don't yet know how that moment will resolve. Meanwhile, 3I Atlas continues its journey through the inner solar system, indifferent to human speculation about its nature. It moves according to the laws of physics and possibly according to programming we don't understand, following a trajectory that was set before our species learned to make fire, let alone telescopes. In 6 weeks, it will swing past the sun and begin its voyage back to interstellar space. In 6 months, it will be beyond the orbit of Jupiter, too distant for detailed observation. In a year, it will be gone, just another point of light among the stars, impossible to distinguish from background objects without knowing exactly where to look, unless we do something, unless NASA or someone else decides that this opportunity can't be allowed to pass without direct investigation. Unless a mission launches in the next few weeks, carrying instruments capable of examining 3I Atlas at close range, photographing its surface, analyzing its composition, perhaps even attempting communication, if protocols can be developed in time. The technical challenges would be immense. The fastest spacecraft humans have ever launched, the Parker Solar Probe, which uses the sun's gravity to accelerate to extreme velocities, reaches about 700,000 kilometers per hour at its fastest. That sounds impressive until you realize that 3I Atlas is traveling at 31.6 kilometers per second, about 113,000 kilometers per hour, and in a direction that would require any pursuing spacecraft to not only match that velocity, but also execute complex orbital maneuvers to achieve rendezvous. Rough calculations suggest that reaching 3I Atlas with current propulsion technology would require either a launch vehicle significantly more powerful than anything currently operational, or a spacecraft already in space that could be repurposed and accelerated using gravitational assists. Neither option is simple, and both would require authorizations and funding that would normally take months or years to secure. But these are not normal circumstances. If NASA concluded that direct examination of 3I Atlas was critical, if they determined that the evidence suggested something so important that it justified extraordinary measures, they have mechanisms for fast-tracking decisions. Emergency funding exists for planetary defense missions. International cooperation protocols can be activated for events of global significance. The bureaucratic barriers that normally slow space missions could be bypassed if the political will existed to do so. Whether that political will exists is unclear. The decision would need to come from the highest levels of government, would require coordination between the White House, NASA headquarters, the Department of Defense, and likely multiple foreign governments. It would be expensive, risky, and controversial. It would make official what has so far been only implied, that humanity is treating 3I Atlas as something potentially artificial, something worth extraordinary effort to investigate, and it would be public. A crash mission to intercept an interstellar object couldn't be hidden. The launch would be visible. The mission operations would be tracked by amateur radio enthusiasts and satellite watchers. The funding reallocation would leave traces in budget documents. The attempt itself would confirm what many already suspect, that 3I Atlas is not just an unusual space rock, but something that demands humanity's urgent attention. Perhaps that's why such a mission hasn't been announced. Perhaps the calculation has been made that the political and social consequences of openly treating 3I Atlas as potentially artificial are worse than letting it pass uninvestigated. Perhaps there's concern that announcing a mission would trigger panic, or international competition for first access, or religious and philosophical upheaval that societies aren't prepared to manage. Or perhaps the mission is already being planned in secret, developed in classified programs with code names we don't know, preparing for launch from facilities that don't appear in public records. This wouldn't be unprecedented. The U.S. National Reconnaissance Office has launched dozens of satellites whose purposes remain classified decades after deployment. The Department of Defense maintains spacecraft and propulsion systems whose capabilities are unknown to civilian observers. If there were political will to reach 3I Atlas while maintaining secrecy about the attempt, the infrastructure to do so exists. But secrets of that magnitude are difficult to maintain in the modern information environment. Too many people would need to be involved: engineers, mission controllers, scientists, support personnel. Too many pieces of evidence would be visible: rocket launches, telemetry signals, budget allocations. Unless the operation were extraordinarily compartmentalized, information would leak. And information is already leaking. Tonight's accumulation of statements, presentations, forum posts, and leaked data points represents a system of secrecy under pressure, containers of information developing cracks through which truth is beginning to flow. Each crack is small and individually deniable, But collectively, they paint a picture that's becoming impossible to ignore. The composite image emerging from these fragments is this. 3I Atlas is an object of extraordinary nature, displaying characteristics that challenge our understanding of what natural processes can produce. Multiple independent lines of evidence suggest it may be artificial, a piece of technology from beyond our solar system. NASA and international partners have detected this and are attempting to study it while controlling the narrative around the discovery. But that control is failing as too many observers, both professional and amateur, notice the same anomalies and begin asking the same questions. We are living through the collapse of the assumption that humanity is alone, the dissolution of the certainty that intelligence is unique to Earth. And it's happening not through a single dramatic announcement, but through the accumulation of technical observations, the careful wording of official statements, the implications visible in what's said and what's left unsaid. This is not how first contact was supposed to happen. The cultural imagination prepared us for dramatic scenarios. Alien spacecraft arriving with impossible technology, radio signals carrying clear messages from distant civilizations, face-to-face meetings between species divided by biology but united by curiosity. We were not prepared for ambiguity, for an object that might be a probe or might be a natural formation we don't understand, for evidence that requires expertise to interpret and institutions to validate. But this is how it's happening, messily, uncertainly, with scientific papers and forum posts and leaked data and careful bureaucratic language all mixing together into a narrative that doesn't follow the clean arc of fiction. Reality is more complex than stories, more fractured, harder to interpret. And the question, are we alone, is being answered not with a yes or no, but with, it's complicated, here's the data, draw your own conclusions. Except we're not really being given the data. Not completely, not in a way that allows independent verification of the extraordinary claims being made. That's the frustration driving the amateur astronomy community's response, the reason Klaus Richter organized his distributed observation campaign, the motivation behind the efforts to archive and share whatever information can be gathered before it disappears into classified databases. There's a democratic principle at stake here, beyond the scientific question of 3I Atlas's nature, the idea that all humanity has a stake in this discovery, that the answer to whether we're alone shouldn't be the private knowledge of government officials and cleared researchers. If there's something from beyond Earth in our solar system, if we're being visited or observed or simply passed by, that information belongs to everyone. But the counterargument has weight too. If 3I Atlas is artificial, if it represents technology from a civilization that might be monitoring humanity's response to its presence, then how we handle that response becomes a matter of species-level importance. Uncoordinated attempts at communication could send conflicting messages. Public panic could lead to irrational decisions. International competition for access could create conflicts that damage humanity's ability to present a unified response. These are legitimate concerns. The problem is that using them to justify secrecy creates a system where small groups of people make decisions that affect all humanity without accountability or input from those who will bear the consequences. It concentrates power in institutions that may not represent the diversity of human perspectives on what contact with non-human intelligence means or how we should respond to it. There's no easy resolution to this tension. Both transparency and coordination are valuable, and in this situation they're in conflict. The approach that seems to be emerging, gradual disclosure through increasingly explicit official statements while maintaining control over detailed data, may be an attempt to balance these competing values. But it satisfies no one, and creates an information environment where speculation fills the gaps left by official silence. And the speculation is becoming increasingly sophisticated. Online communities dedicated to analyzing 3I Atlas have developed their own expertise, teaching themselves astrodynamics and spectroscopy and signal processing in order to understand the fragments of data they can access. These amateur analysts aren't just consuming information, they're generating it, conducting their own observations, developing their own models, sometimes reaching conclusions that professional astronomers confirm privately, even while refusing to acknowledge publicly. One such analysis, posted this evening by a user going by Astrodrift on the Astrodynamics subreddit, has generated significant attention. Astrodrift examined the trajectory corrections that NASA published for 3I Atlas, paying particular attention to the timing and magnitude of the adjustments. What they found was a pattern. The trajectory corrections became more frequent and more significant as 3I Atlas approached the plane of the ecliptic, the flat disk where most planets orbit. This pattern is significant because it suggests that 3I Atlas might be responding to its environment, adjusting its course as it detects the higher density of planetary bodies and artificial satellites near the ecliptic plane. A natural object wouldn't do this. Its trajectory would be determined purely by gravitational forces and any outgassing thrust, neither of which would show correlation with orbital plane crossing. But an active probe designed to study solar systems might very well alter its trajectory to optimize its approach through regions of interest. Astrodrift's analysis included simulations showing that the observed trajectory corrections, if they continue following the detected pattern, would result in 3I Atlas passing significantly closer to Earth than initial predictions suggested. Not close enough to pose an impact threat, the object will still remain more than 1 million kilometers away, but close enough that a spacecraft launched to intercept it would have a much easier time achieving rendezvous. It's almost, Astrodrift wrote, like it's coming here deliberately, like it wants to be examined. This suggestion has sparked intense debate. Some commenters argue that attributing intentionality to trajectory adjustments is anthropomorphizing, projecting human motivations onto what might be purely automated responses to detected gravitational fields or solar radiation. Others counter that if 3I Atlas is artificial, then any distinction between intentional and automated becomes semantic. The object's programming represents the intention of its designers, however distant in time and space those designers might be. And some suggest something more unsettling. That if 3I Atlas is aware it's being observed, if it has been cataloging our radar pings and telescope observations, then it might be adjusting its trajectory specifically to facilitate closer examination, that it wants us to study it, that this encounter is not accident but design. This moves us into territory that feels simultaneously like science fiction and like the logical extension of treating 3I Atlas as technological. If it's a probe, it was sent for a purpose. That purpose presumably includes gathering information about solar systems, planetary bodies, and any civilizations those bodies might harbor. Detecting intelligent life capable of spaceflight and electromagnetic communication would be a primary mission objective, the kind of discovery that might trigger special protocols in the probe's programming. What would those protocols be? Would the probe try to establish communication? Would it gather detailed observational data and transmit it to some distant receiver? Would it modify its behavior to provide better opportunities for the civilization to study it, recognizing that facilitating their investigation serves the probe's information-gathering purpose? These questions assume a level of sophistication in the probe's artificial intelligence that might not exist. It might be nothing more than a sophisticated sensor platform, capable of basic navigation and data collection, but not true autonomy or strategic reasoning. Or it might be something far more advanced than contemporary human AI, the product of a civilization with centuries or millennia more experience in developing machine intelligence. We have no way of knowing. We're projecting human capabilities and assumptions onto something that might operate according to principles we can't anticipate. This is the fundamental challenge of trying to understand any artifact from a technological civilization. We're limited by our own conceptual frameworks, our own experience of what technology can do and how intelligence manifests. But we can observe what 3I Atlas does, and those observations provide constraints on speculation. Whatever it is, whatever its level of capability, its actions are visible and measurable. It's adjusting its trajectory. It's maintaining thermal homeostasis. It may be transmitting signals. These are facts, However, much uncertainty surrounds their interpretation. And one more fact became clear approximately 30 minutes ago, based on observations from the Magellan telescopes in Chile. 3. I Atlas is rotating faster. The object's rotation period, which had been holding steady at 11.3 hours for weeks, has decreased to 10.8 hours. This change occurred gradually over the past 72 hours, too slowly to be an abrupt reorientation, but too quickly to be explained by any natural process that could affect a kilometer-scale object's angular momentum. Changing an object's rotation rate requires torque, a force applied at a distance from the center of mass. For natural space objects, the only available sources of torque are gravitational gradients, which are negligible for an object 3I Atlas's size at its current distance from any planetary body, and momentum transfer from outgassing jets, which the spectroscopic data rules out. There's no natural mechanism that could have produced this change, but there are artificial mechanisms, internal gyroscopes spinning up or down, mass redistributed within the object's structure, control moment gyroscopes of the kind used on spacecraft to adjust orientation without expending propellant. These are engineering solutions, technologies that require design and fabrication and power sources. The implication is clear, even if no official source will state it explicitly. 3I Atlas is actively modifying its dynamic state. It's not passively tumbling through space, but exercising control over its rotational motion, changing its spin rate for reasons we can observe but not yet understand. Why would it do this? One possibility is that the changing rotation rate is optimizing the object's orientation for observation as it approaches perihelion. A faster spin might allow sensor systems to scan a wider area of sky more frequently, gathering data on the inner solar system's planetary positions, satellite populations, electromagnetic emissions. Alternatively, the spin-up might be preparation for some other activity deployment of structures that have been retracted during interstellar cruise, activation of systems that require specific orientations to operate. Or it might be a signal, a deliberate change designed to be noticed by observers, a way of saying, I am not a rock, I am something that can act. This last interpretation feels like anthropomorphizing again, attributing conscious communication to what might be purely functional behavior. But if we take seriously the possibility that 3I Atlas is a probe designed to interact with encountered civilizations, then signaling capability through observable changes makes sense as a design feature. How else would a probe from a civilization using different communication protocols, possibly different physics conventions, possibly different conceptual frameworks entirely, indicate its nature to observers who might initially mistake it for a natural object? You change your behavior in ways that natural processes can't produce. You demonstrate control. You create patterns that demand interpretation as signals rather than noise. The golden ratio spacing in the spectral absorption features, the precise 11.3-hour rotation period that held steady for weeks before changing, the correlation between orientation and acceleration, the thermal uniformity, the brightness spike that lasted exactly 17 minutes. These could all be functional requirements of the probe's design, but they could also be signals, markers of artificiality embedded in every observable property. And we're noticing them. Through professional telescopes and amateur observations, through spectroscopy and photometry and radar ranging, through the collective effort of thousands of people who have looked at 3I Atlas and seen something that doesn't fit, we're reading the message encoded in its physics. The message is, I am not natural. I am made. I come from somewhere else. I am here, passing through your system, and you have noticed me. What happens next depends on decisions being made in rooms we can't see by people who have access to information we don't possess. But the direction is becoming clearer. The careful language of today's NASA statement, the IAU's acknowledgement that new classification frameworks might be needed, The increasing frequency of leaks and unofficial confirmations, all of this points toward eventual formal acknowledgement that 3I Atlas represents something unprecedented in human experience. That acknowledgement might come as a carefully prepared statement, released through official channels with appropriate scientific context and institutional authority backing it. It might come through a leak that forces NASA's hand, a disclosure that happens because information can no longer be contained. It might come through actions rather than words, a mission launch that makes explicit what has been only implied, a spacecraft on its way to rendezvous with an object that everyone will then understand is being treated as potentially artificial. Or it might not come at all. It's possible that the ambiguity will be maintained indefinitely, that official statements will continue acknowledging anomalies without confirming the artificial hypothesis, that 3I Atlas will be studied intensely by classified programs while public discourse remains trapped in speculation and debate. This seems like the least likely outcome given the momentum of information flow, but institutions have successfully maintained secrets more significant than this for decades when sufficient political will supported that secrecy. What we're living through is a negotiation between truth and control, between the reality of what 3I Atlas is and the institutions that believe they have the authority to decide when and how that reality is revealed. The negotiation is happening in real time, with each new observation shifting the balance, each leak eroding the foundation of official secrecy, each public discussion making it harder to maintain the fiction that nothing extraordinary is occurring. And underlying all of this is the object itself, indifferent to our bureaucratic struggles and philosophical debates. 3I Atlas moves through the solar system according to trajectories determined by gravity, radiation, and possibly by programming executed by systems that were designed when humanity was still living in caves. It doesn't care whether we understand it, doesn't care whether we acknowledge its nature, doesn't care whether NASA issues a statement or maintains silence. It simply is a piece of technology from beyond Earth, the physical manifestation of the answer to the oldest question we've ever asked. Because that's what all of this means. Beneath the technical discussion and institutional maneuvering and careful qualification of every claim, we are not alone. Intelligence exists beyond Earth. Civilization has arisen somewhere else in the galaxy and has developed technology capable of crossing interstellar distances. And evidence of that civilization has arrived in our solar system, visible in our telescopes, measurable with our instruments, undeniable for anyone willing to look honestly at the data. This is the conclusion that today's NASA statement approaches asymptotically the truth that's implied by their language about anomalous readings and atypical properties and material characteristics inconsistent with natural formation. They're not quite saying it, not yet stating explicitly that 3I Atlas is artificial, but they've acknowledged that it might be, that the possibility must be seriously investigated, that our understanding of what's out there needs to expand to accommodate this object. And once that acknowledgement is made, once an institution like NASA says publicly that they're investigating whether an interstellar object might be artificial, the intellectual and cultural ground shifts beneath us. The question moves from, could we be alone, to how should we respond to not being alone? The debate shifts from skeptics and believers to pragmatists and visionaries, from whether to what now. This shift is already happening in the communities that have been following 3I Atlas closely. The discussions in astronomy forums and social media platforms have moved past arguing about whether the object is natural. People are asking instead what it means if it's artificial, what implications follow from that conclusion, how humanity should coordinate its response. Some are calling for immediate attempts at communication, suggesting that we broadcast signals toward 3I Atlas containing mathematical proofs, physical constants, images of Earth and its biosphere, the classic SETI messages adapted for a target that's actually in our solar system rather than light years away. Others argue for caution, noting that we have no idea what protocols govern the object's response to communication attempts and that triggering unintended reactions could be dangerous. Still others advocate for a purely observational approach. Study 3I Atlas intensely while it's within range, but don't interact. Don't reveal more about ourselves than our electromagnetic emissions already have. Learn what we can without drawing attention to our presence. This perspective treats first contact as something to be managed carefully. A situation where humanity's response could have consequences that last for generations or longer. And some voices, though a minority, suggest that we should attempt to capture or disable 3I Atlas, if possible. That a piece of alien technology represents both an extraordinary scientific opportunity and a potential threat that shouldn't be allowed to leave the solar system without investigation. These proposals vary in their specifics from sending a spacecraft to retrieve samples to more aggressive suggestions about intercepting and studying the object at close range. But they share an assumption that humanity has both the right and the responsibility to actively engage with the situation rather than simply observing from a distance. None of these perspectives has been adopted as official policy, nor is it clear who would have the authority to set such policy. NASA can coordinate observation campaigns and scientific investigation, but decisions about communication attempts or interception missions would presumably involve higher levels of government and international negotiation. The United Nations Office for Outer Space Affairs has protocols for responding to detection of extraterrestrial intelligence, but those protocols were written for signals from distant stars, not for objects already in our solar system. We're in uncharted territory, legally and diplomatically, as well as scientifically. The frameworks we've developed for space exploration and astronomical research were built on the assumption that we wouldn't encounter artificial objects from other civilizations. That assumption has been overturned, or at minimum has been seriously challenged, and the institutional structures haven't caught up to the implications. This lag between reality and institutional response creates the space where today's situation exists. An object in our solar system that might be artificial, displaying properties that demand explanation. Being studied by multiple national space agencies, but without clear public acknowledgement of what that study is finding. It's a liminal moment, a threshold state where the old certainties have dissolved, but new ones haven't yet crystallized. And it won't last. Moments like this never do. The ambiguity will resolve one way or another, either through official confirmation that fundamentally changes humanity's understanding of its place in the universe, or through a determined effort to maintain deniability that might succeed temporarily, but will eventually collapse under the weight of accumulated evidence. My assessment, based on the trajectory of information flow and the pattern of official statements, is that we're weeks away from explicit acknowledgement. The language is becoming too specific, the leaks too frequent, the astronomical community too aware of what the data shows. NASA's statement today was supposed to quiet speculation, but its careful wording has done the opposite. It's confirmed that the speculation has substance, that the anomalies are real, that something unprecedented is occurring. The next statement will need to go further, and the one after that will need to say plainly what is currently only implied. That humanity has detected evidence of extraterrestrial technology, that the object, designated 3I Atlas, represents contact with intelligence from beyond Earth, that we are not and have never been alone in the universe. When that statement comes, and it will come, whether NASA wants to issue it or whether events force their hand, it will mark a boundary in human history. There will be the time before we knew, and the time after. The before time, which includes all of human civilization up until that moment, when we wondered and speculated and hoped and feared about what might be out there. And the after time, when we know for certain that intelligence exists beyond Earth, when we have to live with the implications of that knowledge. We're living in the last days of the before time. The sun is setting on the age of uncertainty, and what's rising on the horizon is either the dawn of a new era of cosmic awareness or something we don't yet have the concepts to describe. Either way, what NASA said today wasn't the end of speculation, it was the beginning of confirmation. And 3I Atlas keeps moving, spinning faster now, adjusting its trajectory in ways that natural processes can't explain, carrying within its structure or its programming or whatever substrate holds its purpose, the answer to questions humanity has asked for thousands of years. We noticed it. We saw the anomalies. We asked the questions. And now we're waiting for the answer that we've already received, but that institutions haven't yet acknowledged. Yes, you were right to wonder. You were right to look up at the stars and ask if anyone else was looking back. Someone was. Someone is. And they sent 3I Atlas. When NASA spoke today, they didn't just describe a new object. They described a mirror, one that's been looking back at us all along, and for the first time, they said it out loud. Not clearly, not completely, but loud enough that everyone who was listening heard what they meant beneath what they said. The age of solitude is ending. The age of contact has begun. And it started with a small, elongated object moving through our solar system at 31.6 kilometers per second, reflecting sunlight like polished metal, rotating with precision that nature doesn't produce, carrying within it the proof that we've spent our entire history searching for. We are not alone.